My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 590. In this lecture, we will try to understand TensorFlow and Keras overview. In the last couple of chapters, we have actually learned lots of concepts in deep learning, especially with respect to multi-layer perceptrons. If you recall, we have not written a single line of code. The reason we postpone code till now is because most of the high quality code for deep learning. So if you want to write good high quality code in deep learning, it is best to use TensorFlow and Keras. These are some of the most popular libraries. You can also think them as toolkits that enable you to write very high quality code, especially for deep learning. Of course, there are many libraries like TensorFlow and Keras which helps you to write code for deep learning, but these are two of the most popular ones. I will explain you what they are and all of these details in this particular lecture. The reason we postpone the code till now is because I wanted you to get understanding of the concepts first. Once if you understand why each of the concepts are the way they are, writing code is just an enabler. It is just an enabler for you, and that's why we are catering the whole chapter just for TensorFlow and Keras and how to code, how to make it work, things like that. We have to separate out little bit of theory and code, so that you will get good understanding of all the underlying theory. Then we take every that then you can take we learned in theory, isn't it, and we will actually implement in code. If you overlap theory and code, there is a chance that you will miss out the larger picture. That's why we are separating theory and code, isn't it? We wanted you to understand all the theory first, and then we are going to code. Since you understand some theory, some code, I will mix theory and code from now onwards, because TensorFlow is not like it is not like scikit-learn. It is slightly more intricate. That's why waited till now to ensure to understand what's happening in the theory, so that you have better appreciation of the code. You will also understand on how to write code much more efficiently. So with that reasoning, let's understand what is TensorFlow. TensorFlow, probably the most I can say TensorFlow probably the most popular deep learning library as of 2018. TensorFlow was actually open source by Google in November 2015. The best part about TensorFlow that I really love is it is one code library. This is TensorFlow is one code library that helps you to do lot of things. You can do fundamental research. You can if you are a researcher, if you are a fundamental researcher, isn't it? If you are a fundamental researcher and who is trying to come up with new architectures, new algorithms, let me say new architectures and new algorithms, new ideas, TensorFlow is very useful. So it is very useful for researchers. It is also useful for development. So if you wanted to do fundamental research like university professor, hardcore researchers at large companies, TensorFlow is brilliant. Even if you wanted to develop solution to the real world problems, TensorFlow is still very good choice. Even if you want to deploy these models into productions, if you want to deploy these models into productions, because when you are working in real world scenarios, we have to develop models, algorithms, and deploy them into productions, so that they actually make real world impact. Means not only development, it is also useful for deploying, isn't it? So TensorFlow is a single code base. I can say TensorFlow is useful for researchers, development, and deploying models. So TensorFlow is a single code base. I could perform fundamental research, I could do development of algorithms, I could deploy these algorithms. So Google built a toolkit which satisfies all the needs, isn't it? Research development, isn't it? For researchers, this is for hardcore researchers, isn't it? And development means, what is this? This is people like me. The development is, this is people like me who developing deep learning solutions to real world problems, and I am also responsible for deploying the models and make change in real world. So it's one toolbox. I can say it is one toolbox that enables all of it means which is useful for fundamental research, development of algorithms, deployment of models. It is very, very popular. And the best part is this, because some of us good at some languages, some of us good at other languages. The core of the TensorFlow, the core implementation of TensorFlow implemented in C or C++. The reason being, it is very, very fast. The code you write in C or C++ executes very, very fast. Given that deep learning is computationally very, very expensive. Remember, Google has some of the best engineers in the world. So they wrote core fundamental, the crux of the TensorFlow in C++, isn't it? The crux of the TensorFlow in C++ for speed. But the best part is this: they made interfaces available in Python, in Java, and most recently in JavaScript. I think JavaScript launch happened somewhere around March 2018. Today, even if you don't know C or C++ very well, if you know Python, Java, or JavaScript, you can still build TensorFlow based applications or deep learning applications using TensorFlow. So what they have done is they have written the crux of everything in C++, but they made the layer available in Python, isn't it? They made layer available in Python. Python programmers can use Python API. Python API will talk to C++. Similarly, a web developer who knows JavaScript, I can write code in JavaScript and will talk to C++ code to get everything executed. So by making TensorFlow library accessible in multiple languages, somebody who is like a hardcore deployment guy, if you are a software engineer who is trying to deploy a solution, suppose if you built a solution and trying to deploy in production, those people, very good software engineers, may be very, very comfortable in languages like C, C++ and Java. While if I am front-end developer, if I am developing web application, I may be very, very comfortable in JavaScript. While if I am a researcher, most probably even if I am a developing machine learning and deep learning algorithms, maybe I'm more comfortable with Python. Most researchers are comfortable with Python because Python is easier to learn. You don't have to worry about lot of things. So by making TensorFlow available in multiple languages through APIs, even though core is still available in C or C++. So whether you write in Python, Java, JavaScript, whatever it is, the core still continue to in C or C++ to enable high speed. So TensorFlow is super duper powerful, isn't it? Most importantly, today there are versions of TensorFlow called TensorFlow Lite. There is something like TensorFlow Lite, which can run on Android smartphones, especially in Android Oreo version. So if I wanted to develop a mobile application, this is to enable smartphone, this is to enable simpler production or deployment. Suppose if I want to build mobile phone based application, a deep learning application on a mobile phone, I can use TF Lite because it is deeply integrated into Android Oreo and thereby enabling me, making it much simpler for me to do actual deep learning modeling or prediction on Android phone. This is a great way for me to simply deployment, because I may want to deploy my solution. I may want to deploy my solution into Android phone. Just go through this lecture, all these concepts. In my next lecture, that is in lecture number 591, I will continue my discussion why the name, what is the importance, what is the significance of name TensorFlow. All those things I will discuss in my next lecture. Just go through this lecture. If you have any queries, please keep in comment section. Thank you very much.